Welcome to our comprehensive guide on mastering frequency conversion in EViews. This presentation is designed for students and researchers who often encounter the challenge of working with economic data reported at different time intervals. The core idea we'll explore is that data rarely comes in the perfect format for our analysis. The real skill, or mastery, lies in correctly and thoughtfully converting it to meet our needs. Imagine you have quarterly GDP data, but monthly data on unemployment and inflation. To build a monthly forecasting model for GDP, you'll need to convert the quarterly data into a monthly series. This presentation will show you how to do that correctly. So, why is this conversion necessary? Let's start by looking at the fundamental problem that researchers face, the data mismatch challenge. The central issue is data mismatch. In econometrics, we often need our variables to have the same time dimension, or frequency, to run a regression. For example, you cannot directly regress monthly industrial production on quarterly GDP because the time vectors, T monthly and T quarterly, do not align, creating a frequency gap. This isn't a rare problem. Most real-world economic data is mixed frequency. Financial markets give us daily data, while key macroeconomic indicators like GDP are quarterly, and some government statistics are only released annually. Our primary goal is to harmonize these different time dimensions. The challenge is to do this without losing crucial information or introducing artificial patterns into our data. This slide presents a decision map to guide you in choosing the correct path for frequency conversion based on your data needs. The first crucial step is always to identify your source and target frequencies. This initial assessment determines which of the three main methods you will employ. If you are moving from a high frequency to a low frequency, for example, converting monthly data to annual data, you will use aggregation. As the rule of thumb highlights, high to low conversion is an exact mathematical aggregation. Conversely, if you are going from a low frequency to a high frequency, such as converting annual data to quarterly data, you will use interpolation. The rule of thumb specifies that low to high conversion is a statistical estimation process, where you are essentially creating data that doesn't exist in your original series. Finally, for situations involving more complex data structures like panel data, where you need to resize the data while maintaining its cross-sectional integrity, you will utilize a structure resize method. Understanding these fundamental distinctions is vital for accurate data transformation. A flow variable is one that accumulates over a period of time. Think of it like rainfall measured in a gauge. GDP, income, and sales are classic examples. For these, the correct aggregation method is either to sum the values to get a total volume or take the average to get a mean rate. A stock variable, on the other hand, is a snapshot measured at a specific moment in time, like the temperature at noon. Interest rates, stock prices, and the unemployment level are stock variables. The correct method here is to take the first value, the last value, or a specific point value within the period. The crucial question to ask yourself is, does the value accumulate like rain in a gauge, flow, or is it a measurement of the temperature at noon, stock? For instance, quarterly GDP is the sum of production over 3 months, so it's a flow. When converting monthly sales to quarterly, you would sum the 3 months. The unemployment rate at the end of March is a snapshot of the labor market at that point, making it a stock. To get a quarterly unemployment rate from monthly data, you would typically use the last observation of the quarter. Now that we understand this distinction, let's look at the practical application of these methods for high to low frequency conversion. Let's make this concrete. Suppose we have 3 monthly observations, 10, 20, and 30, which form one quarter. If this data represents a flow variable like GDP, we would sum them to get a quarterly total of 60. This is best for volumes, such as GDP. If the data represents a rate or an index like the Consumer Price Index or CPI, we would take the average, which is 20. This method is best for indices or rates. Finally, if it's an asset price, like a stock price, the industry standard is to use the last observation of the period, which is 30. This method is best for asset prices or other stock variables. A pro tip for financial data is that last observation is the industry standard, while for output data, sum is usually required. In summary, average observations are for indices or rates, sum observations are for total volumes, and last observation is for the value of the final period. Interpolation is about creating data points between known values. It's an estimation, not a direct calculation. A key warning is that basic interpolation methods make your chart look smooth but add no new economic information. The constant match method simply repeats the low-frequency value for all the higher-frequency periods within it. This creates a step function. The quadratic match or cubic match method fits a local polynomial through the known points, creating a smooth curve. This can be visually appealing, but may create artificial movements within the period. The linear method simply draws straight lines between the known low-frequency data points. These basic methods are useful, but have limitations. What if we have more information we can use? Let's explore more advanced interpolation techniques. The best practice for interpolation is to use a related high-frequency series, called an indicator, to inform the path of your low-frequency series. For example, you could use monthly electricity usage to help estimate monthly GDP from a quarterly series. The Denton method is a powerful technique that does this. It creates a high-frequency series that both sums up to the original low-frequency totals and follows the movement of the indicator series. Its goal is to preserve the movement by minimizing the volatility of the ratio between the two series. Another method is Chow-Lin, which uses a GLS, generalized least squares, regression to estimate the missing points based on the indicator series. As a best practice, never simply smooth important data if you have a related high-frequency indicator. Always use methods like Denton. In EViews, you can set frequency conversion methods at 3 different levels. First, you can set global defaults for your entire EViews installation under Options and General Options. This is useful if you always use the same method. Second, you can set a series-specific method. By opening a series and going to its properties, you can define a default conversion method just for that variable. Third, and most commonly, you control the conversion at the moment of action using copy and paste special. This method overrides the other two, giving you precise control for each operation. This is the recommended workflow. To summarize the hierarchy, paste special overrides series properties, which overrides global defaults. The critical workflow in EViews is to always use right-click, paste special, not just a simple paste. This opens the interface that gives you full control. In this dialog, you can rename the new series, for example, by adding a suffix like _Q for quarterly. Crucially, you must select Date with Frequency Conversion under Merge By to activate the conversion options. The Frequency Conversion Options section is where you select your method. For high to low, you'll choose Sum, Average, or Last. For low to high, you'll choose Quadratic, Linear, or Denton. Let's convert monthly industrial production, or IP, to a quarterly frequency. First, open the workfile page with your monthly data, select the IP series, and copy it. Next, navigate to the target workfile page, which should be set to a quarterly frequency. Right-click and select Paste Special. In the dialog box, under the High to Low conversion method, select Average Observations. We choose average because IP is an index, not a total volume. As a quick check, always ensure you've selected average for indices or sum for flows, and verify the dates. The example shows input values of 100, 101, and 102 for January, February, and March, respectively. The output for Q1 is 101, which is the average of these 3 monthly values. This process is straightforward. Now, let's tackle the more complex case of converting from a low to a high frequency. This slide presents a case study for low to high frequency conversion, specifically from quarterly GDP to a monthly series. First, as the source, you would open your quarterly page, select the GDP series, and copy it. Next, for the target, you'd open your monthly page and use the Paste Special function. For configuration, you can select quadratic-match average for a smooth interpolation or constant match average for a step function approach. As the observation on the right highlights, the quadratic match method smooths the corners, which can look appealing, but it's crucial to understand that it creates artificial intra-quarter movements that didn't actually exist in the original quarterly data. These movements are estimations, not observed values, so caution is advised when interpreting them. Here's a more advanced scenario. We want to interpolate annual GDP to quarterly GDP, but we have a related indicator series, quarterly industrial production, IP, to guide us. The Denton method uses the quarterly movements in the IP series to distribute the annual GDP figure across the 4 quarters. The result is a quarterly GDP series that is not artificially smooth. Instead, its volatility and turning points track those of the indicator series, making it economically more plausible. At the same time, the sum of the 4 generated quarters will exactly equal the original annual GDP value. A pro tip is that Denton is superior for movement preservation, as it prevents the interpolated series from looking artificially smooth. Let's consider converting a daily panel of stock prices for multiple firms into a monthly panel. First, you need to set up the structure. Create a new workfile page with a monthly frequency and define it as a panel, specifying the cross-section ID and date series. The action is the same. Copy the daily panel data and paste special into the new monthly panel page. For the method, since stock prices are a stock variable, you would select last observation to get the end-of-month closing price for each firm. EViews is intelligent here. It respects the seams between cross-sections and will not mix data from firm A with firm B. A critical issue arises with partial periods. If a quarter is missing data for one of its 3 months, what should EViews do? The Propagate NAs checkbox controls this behavior. By default, this box is unchecked. If you have data for only 2 months, say 10 and 20, EViews will calculate the average of those 2, resulting in 15. This can introduce a risk of bias, as the partial average may not be representative. If you check the Propagate NAs box, the presence of any missing value, NA, in the source period will result in a missing value in the target period. This is generally safer for rigorous academic research, as it avoids creating potentially misleading data points from incomplete information. Never trust a conversion blindly. First, perform a magnitude check. If you converted monthly data to quarterly using sum, did the numbers get roughly 3 times bigger? If you went from monthly to annual, are they about 12 times bigger? This is a quick sanity check for flow variables. Second, do a date check. Make sure the start and end dates of your new series align correctly with the source series. Finally, and most importantly, perform a visual inspection. Always graph the source and target series together. Their trends should align. If they diverge significantly, something went wrong in your conversion method. The EViews command line is significantly faster, especially when you need to convert dozens of series at once in a batch process. The basic command is copy. For high to low conversions, the option C equals A specifies average, as shown in the first example. Copy C equals A, monthly : IP, quarterly : IP. For sum, use C equals S, like in copy C equals S, monthly : sales, quarterly : sales. And for the last observation, use C equals L, as seen in copy C equals L, daily : close, monthly : close. For low to high conversion using the Denton method, you use C equals D and can also specify a row parameter, such as in copy C equals D, row equals 0.9, annual : GDP, quarterly : GDP. This row parameter relates to the GLS transformation used in the underlying Chow-Lin regression. To summarize, frequency conversion acts as the essential bridge for handling mixed frequency data in your analysis. While EViews automates the mathematical operations, it is crucial for you to consciously choose the correct logic based on